Today we'll discuss on the digital electronics practicals. Code is ET209. For the practical, the weightage is 50 marks. Term work weightage is 25 marks and total 75 marks. Now we'll move to the next slide. See, these are the list of the practicals. So if you observe the list of the practical, it contains the 10 experiments, and out of 10 we have to perform the minimum 8 practical to be performed. So starting with the mux, second is again design and implement 4 variable function using the mux, full adder, subtractor, 3-bit code converter, 4-bit comparator. Then after the fifth number practical, design mod n using the IC74LS9093, then by using 193. Then various parameters of CMOS and ring counters. After that, we'll see the respective about the total list. We have to perform the any 8 practicals. So for performing this practical, we require some softwares. Okay, virtually we are performing the practical now. So for performing this virtual practical, we have to use vlab.co.in, this website developed by the MHRD Government of India. On this I will demonstrate how the practical we can virtually we are performed. Okay, so see, go into the electronics and communications, and afterwards we see the list of the practicals. Labs are set up. Okay, so the IIT Roorkee, so it's related digital electronics lab. In after that, the list of we visualize the digital electronics IITR. Scroll this website, and then objectives to learn and understand the basic concept of digital electronics. Then see the list of experiment. Okay, so these are the experiment. Is not total experiment is related to our side. Okay, so in our respective we can call it as performing practical. Our fifth number is the comparator practical, and we'll see the 12 number is verify the truth table 1-bit and 2-bit comparator using the logic gates. Okay, in your practical 8-bit 4-bit comparator is there. In our practical fifth number is, I repeat again, I will show you which are the practical demonstrating. Okay, so in experiment number 4-bit comparator. Okay, and implement 4-bit. Okay, so see, I will demonstrate here 1-bit comparator first. Okay, so here go into the theory parts. After them, read the all theory. Okay, this theory part we can read all the theories. Okay, details are given, how it will be designed. Theoretical part is already covered. Okay, so still we have to read this all theory 1-bit and 2-bit binary to comparator. Then by referring this diagram of 1-bit and 2-bit comparator, on the basis of the the few pretest is arranged. Okay, it is not mandatory. If you compare, we can join the pretest. Then go to the procedure. Here read the procedure, how we can proceed for the performing the practical. And next one is your simulations. Okay, if you go into the simulation, again they are showing verify the truth table of 1-bit and 2-bit comparator. Intentionally I have said don't go which practical is possible and which are easy. That for convenience point of view, we are implementing the 1-bit comparator now. Now I will show you in the 1-bit comparator. So in 1-bit comparator, like this is the internal, we'll see the diagram. Okay, so in this diagram, these 3 ICs are required: 04 inverter, AND gate, then your 07402. Okay, so different 3 ICs. For all will be 14 pin. 14 number pin is VCC for all. Then by referring the your diagram, we making such type of connection. Okay, so comparator 1-bit comparator means X value and Y value. Okay, we know that what is the chances or probability X may be greater than Y, X may be less than Y, or X may be equal to y. Like these are the three branches. Okay, so what you have to do, uh, uh, what you have to do, and we have to go into the uh, 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 in the power supply. In power supply, you first start, press this power supply, it will be start now. Press into the go into the power supply is on now. Now keep x is 0, y is 0, both 0 means x equal to y. This LED will be glow. Okay, we'll see now x equal to y. Okay, add in this sequence see x 0, y 0. So in that case, x equal to y. Now consider another case. Okay, if value of x is 1, if I will press here means x is 1, then expected is what? This LED should be glow. See, x plus 1. Now this LED will be glow. See, add this thing. So now see x LED, x is greater than 1. After that, I will close this one and I will on the y. Now see, expected is what? X is less than y. Okay. Now both 1 means both is equal and this is equal to, and like this one the LED will be glow. Okay. So in this way we implemented the 1-bit comparator. 1-bit comparator. In the second simulator, we'll see verifying the truth table. Okay. We know that suppose a is 0, b is 0. So what is your expected output? We know that A is greater than B. Okay. So here is 1 and remaining both are 0, like this one. Okay. So these are we are manually we are calculated, right? Manually we are giving the answer and we can check it. Press the check button. They are saying the correct. Okay. Instead of this one, if we are pressing here 1 and if you are pressing here 0, then they will be showing the incorrect. See now incorrect because A is greater than B. Okay. And in this way we implement 1-bit comparator. Okay, in the simulator form. Okay, now after this one, what we have to do, we can implement a 2-bit comparator also. Same fashion. Okay, see here the 2-bit means x value and y both. Okay, again the same. Apply the power supply on the power supply. Then after that, see the value of x. Both I will set 1, this one and this one means, and these are the both are 0. Now expected is what? X is greater than y, this area. Now in the another case, what we will do, the value of x will be 0, both 0. Okay, and y is the 1 now. Y is the 1. Now see, expected is what? X is less than 1. See, add this thing and we can visualize x is okay. So in this way we can simulate the practicals. Okay, instruction is again given for all the practicals. You can read this instruction. Okay, before performing the practical, go into the simulator. Again in the same way, here you can write the suppose the 2-bit now. So we can write the 2 here. Value is 2. See now it will not accept because in the form of 1 and 0. Then we'll wait for the another number 0. Now see here is what? A greater than B. So expected is here. This is 1. This is 0 and this is 0 and check it. See it is correct. It is correct. Okay. So again check why because A is greater than B. Expected is what? A is greater than B. So here what are the value we are entering? It is in the form of 2 digit. Expected is 2 digit like this one. Then we can call it as it is correct. See now it is correct. Okay, initially why we are saying because it is 2-bit and we are entering a single bit. That's why they are showing the incorrect. Okay, hope so we understood. Okay, so